You better not push me, but you will. You'll push me. And that's the way forces act. You push on something, it pushes back. All right. So the reason wings fly is it's really simple. It's because fluids like air are sticky. They have what they call viscosity. It's like density, but it's also a measure of stickiness, of how quickly it flows, its gooiness. So air has this thing called viscosity, and it tends to stick to the surface, or any surface that it seems to be flowing across. So if I could draw a little picture here, there's this effect called the Coanda effect. Did I spell it? C-O-A-N-D-A, the Coanda effect. And I'm going to show you a video in just a second, but here's the basic principle of an airflow. You got this air, and it's sort of just standing there. And as the wing moves through the air, it's as if the wing was standing still and the air was rushing past it. So think of it as the air rushing past the wing as opposed to the wing going through the air. But either way, when the air hits this surface, it tends to stick to the surface of the wing. It slows down and even stops at the very surface of the wing. And the air just above it starts to, because of the air layers beneath it that are sticky, it starts to hug that surface of the wing. So here's what happens. Far away from the wing, the air doesn't know there is a wing. So it's just going straight, horizontal. But on the wing surface, because the air is hugging the surface of the wing, it's changing direction. So whereas this particle of air, for instance, would normally travel horizontally, because it's hugging the surface, it is being changed in direction, so it has a component that is being pulled down towards the wing. So when the wing essentially pulls that particle of air down off its trajectory, it creates a little negative pressure behind it. So you're pulling it down, and the air is in turn pulling back up on the wing, and it creates suction. So we essentially have created suction on the top surface of the wing, and the air is sucking the wing up into the air. So that's how airplanes fly. So you can take a piece of paper, and I'll do this, and you could just make it thinner, take some of the weight off. And I'll just let it hang here for a second. I'm going to blow across the surface of the air, so the air that I blow out is going to stick to the surface of the paper. It's going to create a little bit of negative pressure, and hopefully it's going to raise the paper up and see if it works. Of course it doesn't work. Okay, it's just a simple little experiment, the Coanda effect. I blew across the top of it. The fact that it's curving and changing direction, it's an acceleration of the air, it's changing direction, and so therefore, because there's an acceleration of the air, there's a force, and the opposite of that force is what's pulling the wing up. Okay, so let me show you I couldn't bring a lab to you, so I just went to YouTube and found somebody doing the Coanda experiment for me. And now how do I do it? Let's see, Control, choose. And if I have an internet connection, it will work. And it doesn't work.
It works. Hit continue and then you have to log into your portal thing.
Yeah.
What did you say?
Hit continue and then you have to log in with your MACC ID.
Continue to the website.
Where do you see
It says not recommended.
Right here?
Yes.
Don't do it.
Unbelievable.
All
Yes,
the way.
use username and password that were given to you. That is so too bad.
Here, just a second.
Okay.
I'll enter mine.
I'm a doctor.
Oh yeah.
Fail.
Okay. Well, if you don't mind trying to get me on, I'll just do a relive of this. All right. So the Coanda effect is the fact that air sticks to the surface, you change its direction because it's hugging the wing, and as a result you get this negative pressure which lifts the wing. On the bottom of the wing, the air moves, and again it's changing direction, right? there's a curvature towards of the wing, it's called camber. And as the wing makes the air change direction, the air is pushing on the bottom of the wing. So now you have two separate forces. You have the air on the bottom of the wing changing direction, it's being deflected by the wing, which pushes the wing up. And on the top, it's being pulled down by the wing, which in turn makes the air suck on it. And so now you've got lift. You've got pressure on the bottom and the top. Both pressures are pushing upwards, and it raises the wing up. Yeah?
Is there a curvature of the wing which optimizes this effect?
Yes. And there's a whole science about it. I'll talk a little bit about it. But yeah, of course, the first thing you think of is what's the best curvature? And then the next question someone asks you is, well, how fast do you want to fly? How much weight are you going to carry? How high are you going to fly? All these things come into effect, right? And depending on what your speed is, or depending on how much you want to carry, or what kind of airport you need to land on, all these things affect what kind of lift that you're going to need and what kind of curvature you're going to have. Do I have an internet connection?
We're waiting on it.
All right, so I'll keep talking. So on the overhead, there's a picture of what a pressure distribution might look like. And looks like a dinosaur in a sense.
You got video.
Nice! The Coanda effect. Okay, so this guy takes a plastic spoon and he just hangs it on a little string or a pair of chopsticks, I think. And he pushes the spoon into the flow of water, and the water, because it's flowing around the back curvature of the spoon, is changing direction and sucks the spoon into its flow. So he's just waving the spoon around. Let's see if I can make the video larger. So then he turns the water on. And he pushes the spoon into the flow of the water. And because the water changes direction, it's sucking the spoon up into the flow. And then he turns the higher flow that he has around the spoon, the more pressure he can generate onto the surface of the spoon, and pulls the spoon even farther. That's called the Coanda effect, and that's why airplanes fly, because the flow is being changed direction by the curvature of the surface that it's traveling on. Okay, so now I want to shut this off, and I don't know how. Here we go. There we go. And I can turn it off. Nice. Okay, so everything depends on this smooth flow across the wing. And here I've drawn this pressure distribution. I'll show it to you in a second up here. So because of the flow over the wing, you've got huge negative pressure on the top, a little bit of positive pressure on the bottom, but you notice all the pressure is upwards, and so that's where you get your lift. And it all depends on the ability of the wing to keep that layer of liquid on the surface of the wing. So one of the problems, you can see where this might be going, one of the problems is that if you get the fluid to go across the surface of the wing too quickly, or if the curvature is too much, then the surface, the fluid will not stick to the surface, and we have what we call separation. Separation of the fluid from the surface. And in particular, there's this little transitional space between the wing and the air. So I told you a minute ago that the air on the surface doesn't move. So if you take a little particle of air, it's stuck to the surface. But the one above it does move, but it's slowed down. It's slowed down by the particle that's just beneath it. And the one above that, it's slowed down by the one beneath it. But progressively, as you start leaving the surface of the wing, the pieces of air are starting to move more and more quickly. So if you look at a velocity distribution, where this is what they call the free stream, far away from the wing,